This is Dr. Kavita Singh, Associate Professor, Department of Civil Engineering, Institute of Aeronautical Engineering. So today we are going to discuss a topic called as geometry of aerial photograph. So in the previous lecture, I hope you remember we have discussed about the aerial photographs, the types of aerial photographs, different types of aerial photos. Now here we are going to discuss about the geometry of the aerial photograph, how the geometry looks like. So before we enter into this topic, I would like to tell you about what are the contents which it covers in this particular topic. So before we discuss about the geometry of aerial photograph, we have to understand what is flight planning, overlap, photographic errors, curational marks, principal point, nadir point, and isocenter. So if we understand this all, then only we are able to understand the geometry of vertical photograph, geometry of oblique photograph. So let us enter to this topic and let us understand first of all what is flight planning. So flight planning means it's like a plan given to the pilot to plan an area from one direction to the other direction. So if we see about the overflight characteristics, aerial photos are generally taken in a direction from north, south or east-west direction along parallel flight lines. So first of all, let us understand what is flight line. Flight line means there is a line decided for the pilot which goes from either north to south, either east to west, right, or west to east. So if it goes west to east like this, or if it goes back east to west, or else from north to south or south to north. So this is the direction which is given to the pilot to go in a direction to capture the ground images for a particular area. So what is a flight line? Flight line are the path that an aircraft takes in order to ensure complete coverage of an area to be photographed. Flight lines are arranged to give a sequence of overlapping photos. So what is overlapping photos? Overlapping photos, when a flight line goes in a direction like this, it has to give a overlap area. If you see, you can see in this figure, like this is the flight which going from a direction from one direction to the other direction. So while going to the direction, it is clicking the pictures, it is clicking the photos. Like let us see, this is photo number 1, it has clicked. This is photo number 2, it has clicked. This is photo number 3, it has clicked, right? So we have photo 1, 2, 3. We have 3 photos here. But here if you observe, we can see here there is an overlapping area. So this is the area which is overlapping area, means common area in photo number 1 and 2, 2 and 3. So always there will be overlapping area in every photo. So it is must, because overlapping photo is required for the coverage of an entire area. So it will sure that there is no area unmapped. That's why the overlapping photos are required. So overlapping will be 2 types, like forward overlap. Further topic we'll understand what is that. Forward overlap, and we have a side lap, right? So this direction, when it goes to this direction, it goes on in a forward direction. So here it will be keep on clicking the forward overlap. When it comes back return like this, it will just capture the images in the same direction. Like here it has started from west to east. Now it will go from east to west, right? So when it goes to east to west, again it will start capturing the same type of photos. That is photo 1, photo 2, photo 3. Now if you see here, between these 2 flight lines, we have a small overlap area here, right? So this is called as side line. Okay. So this is how the flight planning is given to a pilot to map an area. So next, if you see here, this is same information is given in this slide. Like I was telling you, the flight line goes either to east to west, west to east, north to south to north, right? So when it starts, let us say east to west, so flight has taken the direction from here. So this is the starting point, and it will go like this. It will give a one run here, right? So when it goes from here to here, it will start clicking the photos, right? So here if we see, it has clicked one photo here. Suppose this is the area to be mapped. So this is the area to be mapped, right? Let us say this is the ground. This is the ground which to be mapped. So what it will happen, like when the flight takes a direction from here, so it will start clicking the photo. This is photo 1, photo 2, photo 3, right? Photo 1, 2, 3. Now again here it will be photo number 4, photo number 5, photo number 6. So this is the run 1. It has taken run 1. So from run 1, it may cover the entire area with minimum 10 photos, or depending on the scale, minimum 5 photos, or it can be, let us say it can be 15 photos. So that depends on the scale. If the scale resolution is high, it may take more number of photos. If the scale resolution is low, it may take less number of photos. So while taking the photos, if you see here also, if you see, there is an overlap area, right? Photo number 1, photo number 2. Again, there will be overlap area in photo number 4. Again, there will be overlap area in photo number 4. Like this, it will go for run 1. Again, east to west. Now it will start from west to east. So again, it will start from here to here, right? So again, it will start clicking the photo. Photo 1, photo 2, photo 3, photo 4, photo 5. Like this, it will keep on capturing till the end of this flight line direction. So this is how the flight planning is done for an area. I think this plan is given to the pilot to go to a direction from east to west, west to east, again east to west. Okay, so this is run 1, then run 2 you can see, run 3 you can see. Again it is going in this direction, that is run 4, right? Again it is going in this direction, it is run 5. So 5 runs it has taken, the flight has taken to the 5 runs. It is starting from here, ending here. So while to a run direction, it has clicked how many photos? Maybe 10 photos in one run, 10 photos in the other run, 10 photos in the third run, 10 photos in the fourth run, and 10 photos in the fifth run. So total number of photos depending on the scale, as I have told you, if the scale resolution is high, the number of photos will be increased. If the scale resolution is low, the number of photos will be less. Okay, so this is how it goes on. The flight planning is done for an area. So this total area is mapped. This total area is mapped with this kind of flight directions. Okay, this is how the actual photo looks like. Here we have seen the image. Now the actual photo looks like this. So this is the flight line direction. Let us say this is the flight line direction. So this is from west to east it is going. Now again, if it will complete it, again it will go back to the other direction, that will be east to west. This is one direction it is capturing. So here is photo number 1, photo number 1, okay, photo number 2, photo number 3. So total 3 photos you are seeing here, but actually as per the direction decided, it may cover 10 photos, it may cover 15 photos, it may cover 20 photos. Okay, so while going to the forward direction, what it is doing, it is capturing the images of an area. Now if you see here, there is an overlap area in photo 1. This is the overlap area. This is the overlap area. Now in photo 2, this is the overlap area. Now again, if it will capture, this is the photo 4. So here will be overlap area. So photo 1, 2, 3, 4. So like that, it will capture the entire area with an overlap. So this is forward overlap. When it comes back to the east to west direction, now it will capture the same overlap and side lap. So this portion will be common in this photo. This portion will be common in this photo. Okay. So this overlap is called as forward. This overlap is called as end. Okay. So this is how the flight planning direction is given. Now if we talk about overlap, just now I was telling you about the forward and the end lap, or we can say it as side lap. Okay, side lap. So here you see overlap. Aerial photo projects for all mapping and most image analysis. require that a series of exposure be made along each multiple flight lines. So a series of exposure should be made in the multiple flight line with the overlapping photo to make an analysis. So to guarantee the coverage throughout the site, the stereoscopic photograph must overlap in two directions. So if you want to make it sure that the coverage area is totally, it should be covered, the entire area should be covered, no point should be unmapped, then we have to ensure that the photo should be in an overlap manner, right? So here you see in the line of flight, overlap, line of flight means this direction. This is the line of flight. Line of flight we say. Line of flight we say. Line of flight we say, or flight line we say. Flight line. Okay. So we for this flight line we need the overlapping photos for this parallax. Parallax I'll explain you in the coming topics. This is a different topic again. But just understand one thing, parallax, for doing a parallax, we need one pair of overlapping photos. To get a parallax, we have to take a photo as a pair of overlapping photos, right? So in a flight line direction over, need for parallax, and then between adjacent flights to avoid missing bits. Between the adjacent flights means, so as we have seen in the previous slide, there is a run 1 from here to here, right? Run 2 from here to here. So what happens when it is starting from here? So 1 photo, 2 photo, 3 photo, 4 photo, 5 photo, right? When it returns back, again it will click photo, 2 photo, 3 photo. So this portion, this overlap, we call it as side lap, which is between the flight lines, between the adjacent flights. Okay, means run 1 and run 2. So between this, it is called as between the adjacent flights to avoid the missing bits, and it is called as side. Okay. Now, in the next slide here, more clearly you can understand what is forward overlap and what is side lap. Till now we were discussing about this overlaps. Okay, so what is forward overlap and what is side lap? What is forward overlap? Let us understand. So in previous slide also I told you forward overlap is from a flight line direction when it starts from east to west or from west to east. So this is the flight line direction. It is going in a forward overlap. Okay. So this is flight. This is also flight. So it has clicked one photo here. Okay. And the other photo here. Right. And the third photo will be here. So what this area, what you can see here, it is the overlap. Okay. That means overlap means common area in photo number 1 and photo number 2. Common area in photo number 2 and photo number 3. So one pair of photo if you take in a sequence, the overlapping area is called as forward overlap. So the forward overlap always it will be 60 to 70% in a forward overlap. If you take a forward overlap, always overlap will be 60 to 70%. Okay. And side laps between the flight lines is from 25 to 40% and ensures that no area left unphotographed. So that's what it ensures, that the area should be covered. Total entire area should be covered. So this is the ground level and the overlap is 25 to 40. So here you can see this is the area which is overlap. This is 25 to mostly 25 to 40%. Okay. In some cases, it may be up to 30%, right? So this is side lap. So this is one flight line direction, and the other one is this one flight line direction. Okay. So this is how it captures the overlapping area, as you can see here. It ensures that no areas are left unphotographed. I think in the coming on this image you will be understanding more better. So vertical aerial photographic coverage of an area is normally taken as a series of overflight strips Lap is the overlapping of sequence photo along the flight stream. So this is also forward overlap, side lap. So you can see here forward is more, side lap is less, right? This is side lap. Now if you see here in this image, here it is more clear to understand. So this is a flight line. This is the flight line direction. So it is taking photo 1, 2, 3, 4, 5, 6. So total number of photos what we can see here is total 6 photos we have. So out of that 6 photos, here we can see there is overlap area, right? This overlap area, this is overlap area, this is the overlap area, and this is the overlap area. So what would be this overlap area is called as? This overlap is forward. Okay, forward overlap. Now down you see there is a small portion here. This one, this one. This we call it as end lap or side lap. Okay. Now see in this photo, this is one flight line and this is the other flight line, right? Now you see here photo 1, photo 2, photo 3, 4, 5, 6. So this is the overlapping, right? This is the overlapping, overlapping. Now this is forward, right? Again going back, this is the side line. As we have discussed in the previous slide, this is between the flight lines. So this is flight line 1, and this is flight line 2. So between flight line 1 and flight line 2, this kind of overlap we call it as forward, call it as end lap and side lap. And to a sequence of photos in a forward direction, it is called as forward overlap. So always remember the forward overlap will be more compared to the side lap, because side lap is between the flight lines, whereas forward overlap between the photos, photo 1, 2, 3, 4. Okay, so forward overlap is more. It will, in most of the cases, it is 60 to 70%, up to 80% also overlap we can find. So if you take a one pair of photo 1 and photo 2, you may see that 80% of area is common. 80% of area is common in these two photos. While as flight line direction, when you talk about this flight line, between the flight line, that means flight line 1 and flight line 2, the overlap always it will be 25 to 40%, in some cases 30%, in some cases 20%, because that just because for ensuring this area should not be unmarked. Okay, I hope you understood about this forward overlap and the end lap, and why it is important. It is important for parallax first of all. Second thing, it is very much important for 3D view. And third thing, it is very much important that no area should be unmarked. There should not be a small area even missed out of this flight line direction. So if this is the flight line, so 1, 2, 3, 4, total area should be covered. That's why it is ensured that forward overlap and end lap is must. It's very important in the aerial photographs. Now let us understand what are the different errors we come across while clicking the photos. When a pilot is going to a direction from east to west or west to east, and goes from east to west or west to east, north to south or south to west, north to south, south to north. What will happen basically, every time the weather conditions are not same, always it is not same. Sometimes it is sunny, sometimes the weather is too cloudy, sometimes the weather is too windy, and sometimes the sunlight is not available proper. So in that case, what happens at the time of capturing the photos, what happens generally, when a pilot goes to a direction, when it tries to goes to a direction, what happens when it want to go from this to this is the flight line direction. So due to the wind conditions, due to the unfavorable weather conditions, what happened? When it has to go from here to here, it will go zigzag, up and down, up and down. So when the photos to be clicked, if it is, this is the flight line direction. So when the photos to be clicked like this, like this, like this. Okay, so what happens due to this weather conditions? What happens? The photos will be somewhat like this, like this, like this, up and down. So this is not the proper way of getting the information of the ground. We can see here lot of area is missed here, right? This area is not captured, this area is not captured, this area is not captured. So this is a huge error in aerial photography. So we have two types of errors while taking the photographs. So we call it as crab and we call it as drift. Okay, these are the two types of error when a pilot come across while clicking the photos. When a pilot come across clicking the photos, right? So let us understand what is a crab. Crab means so when the flight line direction is decided in this way, let us say west to east or east to west. So you can see here this is the actual flight line decided, actual travel direction. But what is happening due to wind? The wind is pushing the flight. Right? The wind is pushing the flight. It has to go in this way, but what happens? It goes in wrong direction, right? It goes in a outward direction. It goes in a direction which is not at all under the flight line. Okay, so this is the actual flight line, but the flight goes in this direction. So there is an angle formed here, right? So we call this angle as a we call this angle as a crab angle. So let us understand here. Crab is a disparity in the orientation of the camera in the aircraft with respect to the aircraft actual travel direction. It is usually the result of side winds which cause the aircraft's direction of heading to deviate from its actual travel direction shown in the figure. So it will deviate from the actual flight line direction. If the actual flight line direction is like this, it will go down. So it is deviating. The winds, the weather conditions is deviating the flight from going to the actual flight line direction. So this is called as crab. Okay, crab error. Next you see drift. So drift is the somewhat. This is also basically due to the failure of the pilot to fly due to the wind conditions or weather conditions. So is the term applied to a failure of the pilot to fly along the flight lines. So it is the term applied to a failure of the pilot to fly along the flight lines. It is often caused by strong winds. As I have told you, it is often caused by the strong winds. Even the crab is also error formed due to the strong winds. So excessive drifts are also most common cause for gaps in the photography, and this occurs reflight are necessary. So now see, this is the actual flight line direction and drift. What happens? See here, photo 1 is here, photo 2 is here, 3 is here, 4 is here, 5 is here. Okay. So this area is unmapped, this area is unmapped, this area is unmapped, this area is unmapped. So lot of area is not covered. Okay. So this is one photo. This is the other photo. This is the third photo. This is the fourth photo. This is the fifth photo. A lot of up and down. So total up and down flight direction will be like this, up and down, up and down. Like a turbulence will happen due to wind conditions. So flight goes up and down. So due to that, this kind of photos appear. So this is totally waste to further if you want to find any analysis or results due to this. This is totally waste for mapping purpose. So the pilot has to plan this flight line direction again to capture the same area. So if this area to be captured, what happens? So much area is unmapped. This much area is unmapped. This much area is unmapped. Okay, so this is a huge error in the photographic error while taking the photos. So what are the errors? We have crab, we have drift. So these are the two types of error. Now see here. Here normal way it is shown. So this is the drift. This is the normal way of photo to be taken. So if the flight line direction is proper, if the weather conditions are proper, the flight line goes in a proper direction. Right? So here there is, you can see photo 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 photos it has taken and there is no areas. You can see the total area is covered here. Right? Total area is covered. By this you see drift, as I was saying, explaining you in the previous one. So due to wind, what happens? This is photo 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you can see here this area is unmapped, this area is unmapped. So this total huge error, the area which is decided to be mapped properly. So this area is unmapped due to the wind weather conditions. Now crabbed angle, as I told you, if the flight line direction is straight, it will go to the other side. Okay, so these are the two errors we come across while taking the photos. Okay. Next, before we enter to the geometry of aerial photograph, we have to understand these all terms, because this is totally related to the geometry of the vertical photograph and the oblique photograph. So let us understand about this fluorescent marks. So this is one aerial photo. This is one aerial photo. You can see here. Okay. This is one aerial photo. You can see here. There are marks on the corner, on the side center of the photo. Okay. These are the marks you can see here. Mark 1. You can see here, there is a mark here, like V-shaped mark here. Okay. So this kind of marks is called as fluorescent marks. Fluorescent marks. So fluorescent marks is a set of marks located in the corners or centers or both of an aerial photographic image. So it is located in the center of each side of photo. Okay. So what is this purpose of fluorescent marks? This is very important to understand the geometry of the aerial photograph. So this will be available on all the photographs. Every aerial photo you will see that there are marks like this. Every aerial photo you can see this 4 marks on the side of each side of the aerial photo in the center. Okay? So these marks are exposed within the camera onto the original film and are used to define the frame reference for the spatial measurements of the aerial photographs. So if you want to measure a height of the building, if you want to measure the height of the object, these marks are very much important. This marks plays a very important role to further measurements for any kind of objects. Okay, so these are called as fluorescent marks, and these are very helpful to understand the geometry of the aerial photograph. Now, if you see a next principal point, so this is one more terminology used to understand about the geometry of the aerial photograph. So as you have seen in the previous slide, you have a fluorescent marks here, right? Now in the same photo, you can see this is the fluorescent mark, this is the fluorescent mark, this is the 4 fluorescent marks. So how the principal point is obtained? How the principal point we get to know. So if you join this 4 marks, okay, let us join this 4 marks. So from here to here I join, from here to here. Okay. So when I join these 4 marks, I get a center. Okay. So this center we call it as principal point. Okay. Center we call it as principal point. So what is it? Principal point. So what is principal point? So when you join these 4 marks together, we'll get a center. Okay, we'll get a center. This center is called as principal point. So opposite judicial marks connected intersect at approximately the image center or principal point of the aerial photograph. The principal point is a geometric center of the photograph. So it is the geometric center of the photograph, where you can see it is a geometric center of the photographs. it will give the center of the photograph. If you want to find out the center of the photograph, if you join all these 4 marks, judicial marks, you will get the center of the photograph. So this is called as principal point, judicial marks, principal point. Now let us understand what is nadir point and what is isocenter. So these are different terminologies. We use it to understand the geometry of the aerial photograph. Okay, so what is nadir point? Nadir point, let us understand. So if the flight is here and the optical axis, that is camera, it is here, and this is the area to be captured. Okay, so exactly below the camera, okay, here is your exposure station and here is the ground point. Okay, so exactly vertical to the ground is called as nadir. We call it as nadir point, which is exactly vertical to the ground. We call it as nadir point. Okay, so nadir is the point vertically beneath the camera center at the time of exposure. So here is your optical axis, here is your exposure station. Here is your exposure station. Okay, here is your exposure station, and exactly beneath the camera is called as nadir. So in the vertical photograph, your nadir point, your principal point will be same. Okay, we call it as PP. Principal point we call it as PP. So in a vertical photograph, principal point and nadir point is same. Okay, in a vertical photograph, just remember that. When you are seeing the geometry of the vertical photograph, their principal point and nadir point is same. So principal point will be exactly here, nadir point be exactly here, right? Whereas when you see a tilted aerial photograph means obviously it's a oblique photograph. So oblique photograph, it will be low oblique or high oblique. So in an oblique photograph, you will see nadir point is different, principal point will be again different. So if the exposure station is somewhat here, okay, so nadir point will be somewhat here, right? So if the camera is somewhat here, nadir point is here, and the principal point is somewhat here. Okay, so because we are in our oblique photograph, it's not vertical. It is inclined with 30 degrees angles and 60 degrees. We have studied in the previous lecture. We have low oblique and high oblique. So in a low oblique photograph, it is inclined with 30-degree angle. In high oblique, it is inclined with 60-degree angle. Right. So if in that kind of photo, for example, here is the exposure station. Here is the exposure station, and if here is the nadir, right? Here is the nadir. So your principal point will be somewhat here. Okay, this will be your PP. Like in this, you can see here, nadir is here, principal point is here. So because your photo, what you are taking, it is not vertical. So your photo will be somewhat like this. Okay, the photo will be somewhat like this. So this is if your principal point is, let us say, this is your photo. Okay, so this is your photo. So here is a principal point, here is a nadir point, and there is a term called isocenter. Okay, isocenter is, this is the isocenter, which falls halfway between the principal point and the nadir. Okay, so isocenter is between nadir and principal, the point between nadir and principal point. Okay, so principal point is the center of the photo. We have seen in the previous slide, principal point, if you join all the judicial marks, all 4 fiducial marks, we'll get a point called as principal point. So this is our tilted photograph, that is oblique photograph. So where you can see principal point is here somewhere, another point is here. Whereas the center, the point between the nadir and the principal point is called as isocenter. Okay, so I hope you understand the term about nadir point, isocenter, principal point. So principal point, when you join all the 4 fiducial marks, you'll get a center called as principal point. What is nadir point? Nadir point is exactly beneath the surface of the camera. Okay, so exactly beneath the camera, the ground exposure is called as nadir point, whereas isocenter is the point on the photo that falls on the half line halfway between the principal point and the nadir. These are the different terms we have to understand before we understand the geometry. Okay. Now let us understand the geometry of the vertical photograph. Okay. I hope you remember what is vertical photograph. So this is how the vertical photograph looks like. Okay. Now if you see, this is the ground to be covered. This is the ground to be covered. That is A, B, C, and D. So this is the actual ground which is to be covered. So in a vertical photograph, when a lens, here is the lens means camera. Okay. So when it clicks a photo of this area, A, capital A, B, C, D, when it clicks the photo of this area, exactly in a vertical photograph, same type of image is captured vertically. Okay. So if this is your A, B, C, D, so your principal point is here because it's a vertical photograph. So your principal point will be in the center exactly, right? Here. We join these 4 corners, you get the principal point. Same in the positive plane, this will be your principal point. Okay. So small pp, capital PP, right? Now same thing you see A, B, C, D. Now here also you see A, small b, small c, small d. Okay, so this is the image captured by the camera, and the principal point in the photo is here, the principal point on the ground is here. Okay, now if you see the negative plane, in the negative plane also, this is the exposure station, right? This is the principal point. Now always you know that negative is reverse of positive, so negative will be reverse of positive. That's why A is here, B, C, D. So negative photo is captured and the positive photo captured, and common thing is here is the principal point will be same in the ground, actual ground, same in the positive plane, and same in the negative plane. Okay, so this is how the geometry of the vertical photo looks like. And here if you see altitude above the sea level, this is the focal length, and this is the flying height from here to here. This is the flying height required. So flight is here, and from this altitude only this photograph is taken. And if you see here, photographs taken from an aircraft with the optical axis of the camera vertical or as nearly vertical as possible are called vertical photographs. If the optical axis is exactly vertical, resulting photograph is termed truly vertical. In spite of precautions taken to keep the camera axis vertical, small tails are invariably present. So whenever they try to take a vertical photograph, sometimes what happens, even though precautions are taken, sometimes slight tilts are happening. So even though it's a vertical photographs, as we have discussed in the previous lecture, vertical photographs are of 2 types. One is true and tilted. So true and tilted means truly vertical, which is truly vertical to the ground. Tilted means less than, you can see here, less than 1 degree and rarely exceeds 3 degrees. Okay, it is less than 1 degree and rarely it exceeds 3 degrees. Photographs containing this small unintentional tilts are called near vertical tilted photographs, and for many practical purposes, this photo may be analyzed using the relatively simple, truly vertical equations without any serious errors. Okay, now this diagram explanation is given in the next slide. Illustrate the geometry of a vertical photograph taken from its coordinate station L. The negative, which is a reversal in both tone and geometry object space, is situated a distance equal to the focal length is situated a distance equal to the focal length, right? And behind the rear nodal point of the camera lens. Now the positive may be obtained by the direct emulsion to emulsion contact printing with the negative. So this process produces a reversal of tone and geometry of negative, and therefore the tone and geometry of positive are exactly the same as those of object space. Geometrically, the plane of contact printed positive is situated at a distance equal to the focal length below the front nodal point in the camera lens. Okay, the reversal in the geometry from the object space to negative is readily seen in the figure. So reversal you can see here in the figure. So this is the positive plane, this is the negative plane, and this is the actual plane. This is the positive, negative, actual plane. Figured by comparing the positions of objects points A, B, C, D with their respective corresponding negative positions A1, B1, C1 and D1. Okay, here. Now here more clearly we can understand with this diagram. This is the same vertical photograph itself, geometry. Very clearly we can understand here. So here O is camera position. Okay. Now you have a small p here. Okay. Just small p here is photo principle. Okay. So this is your photo, right? This is your photo, and this is your photo principal point. Whereas capital P here is ground principal point. Okay. Ground principal point and the photo principal. Now you have a small p of the photo principal point, and here you have a ground principal point. Okay. Now you have a focal length. Focal length we call it as small f is focal length. That means here will be the camera. Okay. And the photo is clicked off this ground. So here you get an image here. So this is called as focal length of the camera. Now you have a height, flying height. Okay, flying height. You have a flying height here. So capital H is flying height of the aircraft. So flying height of the aircraft, it can be 900 meters, it can be 800 meters, it can be 700 meters. Okay, depending on the scale, the flying height is decided. Okay, so this is how the photo, small photo, and the ground photo. Okay, now you see geometry of low oblique photograph. So same like this, here we can see geometry of the low oblique photograph. So what is low oblique photograph? Low oblique photograph is, it is tilted photograph. Okay, tilted photograph. What is tilted photograph? So tilted photograph we have two types again. That is low oblique and high oblique. So what is low oblique? Low oblique is the tilted photograph with camera inclined with 30 degrees. Okay, we remember in the previous lecture we have discussed. So with a 30-degree angle, it is a low oblique photograph. So here we are just discussing about the low oblique photograph. And high oblique photograph is the camera inclined with a angle of 60 degrees. Okay, 60 degrees angle. So the difference between low and high is here horizon not visible. Okay, here horizon is visible. That is the difference. Okay, so this is the geometry of low oblique photograph. Now if you see here, we have O is the camera position. This is the camera position. O is the camera position. Okay, now here if we go down, here we have the middle. So nadir is always, you remember, nadir point is exactly vertical to the ground. So exactly vertical to the ground is nadir point, which is exactly beneath the camera position. So this is the ground nadir. Okay, and this is the photo nadir. Photo nadir, small n, you can see here, ground nadir point, and this is photo nadir. So now here, principal point is different from nadir point, right? Principal point is different from nadir point. Why we say like this? Because low oblique photograph is the tilted photograph. Okay, so when a camera angle is 30 degrees inclined or 60 degrees inclined, so nadir point and the principal point, this will not match. This will not match at all. So I hope you remember what is principal point, what is nadir point, and what is isocenter. So nadir point is exactly the point beneath the camera. Okay, the point on the ground beneath the camera is called as nadir point. Whereas principal point, when you join, this is the center of the photo. So when you join all the when you join all this fiducial marks here, okay, when you join all these fiducial marks, you get a center called as, okay, principal point. So here is the principal point for this ground, because the image captured is from here to here, okay, because it's a oblique photo. So here is the principal point of ground, and here is the principal point of of photo. Okay, and here if you see, now what is isocenter? Isocenter, I hope you remember what is isocenter. Isocenter is the line between the line which passes through from camera position to the ground. Okay, this line is between nadir point and between principal point. Okay, so this point is called as isocenter. So this is the isocenter of the photo. Okay, photo, and this is the isocenter of the, this is the isocenter of the ground. Isocenter of the ground. This is the isocenter of the ground, and this is the isocenter of the So the geometry of the low oblique photograph looks like this. In vertical photograph, the nadir point and the principal point will be same. Whereas in the low oblique and high oblique photograph, the nadir point and the principal point will differ. Okay, these two will differ. Always it will be different. Right? Now if you see here, geometry of low oblique photograph, the basic relations of lens. The positive point and the ground of low oblique photographs is given in the figure. So figure is the same in this figure. We're talking about the point of intersection of the optical axis of the camera within the photo plane and the ground plane, as referred to respectively as photo principal and the ground principal point. Okay, photo principal point and the ground. So this is the photo principal point and this is the ground principal point. Okay. The point vertically below the camera lens on the ground is called as ground nadir point, and the corresponding usage point on the photo is called as photo nadir point. Okay, photo nadir point and the ground nadir point. The points of intersection of bisector of the angle between camera axis, and the vertical with the photo plane and the ground plane are referred to respectively as photo isocenter and the ground center. Okay, photo isocenter and the ground center. So this was about geometry of the vertical photograph of low and high. So I hope you understood about how the geometry of the vertical photograph and the oblique photograph looks like. So always remember the vertical photograph nether point and the principal point is same. It will match. Okay, exactly beneath the camera is nether point and the principal point for vertical photograph. But whereas for the oblique photograph, the principal point will not at all match because it is having a angle of 30 degrees inclined and 60 degrees inclined. So the always principal point will be different from the nether point. Nether will be always same exactly beneath the surface, but principal point will be always different for the low oblique and the high oblique photo. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.